Good day, grade 12 again. Just a quick reminder of the things that we need to know when we are dealing with question 5. You must know the definitions, the 6 definitions as shown in the previous video. Work energy definition, work energy theorem, the power definition for power, the conservative force, and you should know that conservative force is only weight, Fg, or gravitational force. The non-conservative force, which will be any contact force that we might encounter, tension, friction, or applied force. The conservation of mechanical energy principle. And remember that conservation of mechanical energy is the following formula, which is not given in the formula sheet. Mechanical energy is conserved only when weight is the only force acting. If there's friction, if there's tension or applied force, mechanical energy is not conserved. Or we can say mechanical energy is conserved when F net equals to 0. When there's no external force, or the net external force equals to 0, or there's no acceleration. Yeah, things like that. These are the energy principles you need to know. These 3 energy principles. The work done, the total work done on an object equals the change in kinetic energy is a definition. This one is not a definition, but you have to know how to use it. We said last time these 2 can be used interchangeably. So today I have 2 question papers that I want us to look at. The first one is the following. It's November 2019 final question paper. So let's start by reading the statement and understand fully. An object of mass 1.8 kilograms slides down a rough curved track and passes point A, which is 1.5 meters above the ground, at a speed of 0.95 meters. So point A is here. The object has mass of 1.8 kilograms, and the velocity at this point, let's call this initial velocity, because this is where we start noticing anything about this object, when it's 1.5 meters above the ground at a speed of 0.95 meters per second. The object reaches point B at the bottom of the track at a speed of 4 meters per second. So we hear nothing about the object in between. So we'll take this off as our final point. This will be final velocity. Final velocity is 4 meters per second, and this still going that direction. 5.1, define the term conservative force. Remember, definitions are 2 marks, right? So you don't mess around with those 2 marks. Get all of them. Excuse me. Define the term conservative force. We said last time that the conservative force is a force for which work done in moving an object between 2 points is path independent, or does not depend on a path taken. And that is Fg. The only conservative force we deal with is Fg. 5.2. So this one, the definition was define it and you get 2 marks. 5.2, name. Here they said define. In 5.2 they say name the conservative force. Then the conservative force acting on the object. In this case it will be Fg. If you know it from 5.1, you will remember it for 5.2. 5.3, they asked, is mechanical energy conserved as the object slides from point A to point B? Choose from yes or no, and give a reason for your answer for 2 marks. So 1 mark will be for choosing, then 1 mark for reason. Let's think carefully. Is mechanical energy conserved? Mechanical energy, if you remember very well, is this energy principle number 1. We said it is only conserved when the net external force is 0, or when there is no friction, no tension, no applied force. In this case, the object is sliding on a rough curved track. So since there is friction, mechanical energy cannot be conserved. Mechanical energy, therefore, is not conserved. The answer we write is no. Now the reason is, we can say there is friction. There is friction, or we can say the net external force, F net, is not 0. F net is not 0. Or you can say acceleration is not 0. If you also write acceleration is not 0, that will still hold correct. Any of the 3 reasons, please remember that. Mechanical energy is only conserved when there's no friction, no tension, no applied force. And this is the only time you can apply this formula. So it means we will not be able to use this formula between point A and point B because there's friction. Number 5.4, calculate the gravitational potential energy of the object when it was at point A. Gravitational potential energy of an object when it was at point A. So remember that potential energy is it's EP equals to mgh. It's the formula. It's given. This formula is given in the formula sheet. Or we can say U equals to mgh. We use U or EP. So let's any one of them. The mass of an object, it's 1.8, and G is 9.8. The height above the ground is 1.5. So you put this in a calculator. 1.8 multiplied by 9.8. No, excuse me. 1.8 multiplied by 9.8 multiplied by 1.5 equals to this is 26.46 joules. The unit for energy is joule. Energy and work, they have the same unit. And for doing this, you'll get a mark for the formula. Writing the right formula and use it gives you a mark. So remember to write down everything that's given to you, and remember what they want. You write the formula and apply it. If you write the formula only, like in this case, you'll not be given a mark. Say this was option number 2. The mark for all the substitution, all the numbers should be correct, and then your answer together with the unit will give you another mark. So it's 3 marks. That's how we get 3 marks easily. 5.5, using energy principles. Please always read this question clearly. The examiner will restrict you. You cannot use anything. You should use energy principles. And our energy principles, let's remind ourselves, is the mechanical energy, which applies only when there's no frictional force, no tension, no applied force. And it's work energy theorem. And the last one is work done by non-conservative force. So these are the only energy principles that the examiner refers to. So let's use energy principle, all right, on the side here. Energy principle to calculate the work done by friction, work done by friction on the object as it slides from point A to point B. So now we need the following. Number 1, we should know how many forces act on the object. Let's draw a free body diagram. Free body diagram is very important, grade 12. So when the object is on point A, it has weight. Weight is a force that is there for every object. Remember, all the objects have mass. And another force acting, because it's a frictionless surface, the surface it's a rough surface, excuse me, so there's frictional force which always acts in opposite direction. Another force that acts on an object would be tension, would be the normal force, which is always perpendicular to the surface. So a free body diagram looks like this. It will look like this. The weight, the frictional force in opposite direction, and the normal force. The only forces that do work on this object, it is the frictional force and the weight. The normal force does 0 work. Always remember that normal force does not do work on an object. So we know that there's 2 forces doing work on the object. If we use energy principle number 2, work energy theorem, it will look like this. The total work done equals to the change in kinetic energy. So we first write that one. Remember to write the formula all the time so that you get marks. These are free marks. Work done by all the forces equals the change in kinetic energy, and this will be work done by frictional force plus work done by weight. Let's just write as it is, weight. This equals to change in kinetic energy. Also remember, changing kinetic energy, we can use change in EK or just change in K. That is any one that you choose. We don't have to break this down because they want work done by friction. So let's write it as it is, work done by friction plus this one will be the weight multiplied by, the weight is a force that is facing down, so multiplied by vertical height. Always when you're dealing with weight, it will be multiplied by vertical height and the cosine of the angle between the two. So let's say that is theta. We have done showing the weight. This equals to 1 over 2 mv final squared minus 1 over 2 mv initial squared. Please write it like this to avoid making mistakes. I would prefer that you write it like this to avoid making mathematical errors. Now let's substitute everything that we know. Work done by friction, we are looking for it, plus the weight of an object is mass times gravitational acceleration. So this is mass is 1.8 and gravitational acceleration is 9.8. This is the weight. This is the weight. Multiplied by the vertical height. The vertical height in this case is 1.5 meters. And the cosine of the angle between the two. Now let's think. The weight is the force that is acting downwards, as seen from the Fibonacci diagram. Now vertically, where is this object going? Is it going up or down? Vertically. It doesn't matter whether it moves to the right or left. The weight is not involved in that. That is the duty of, that is, it moves to the right because of the incline. If the incline wasn't there, it was going to fall straight down, maybe with air friction. Now the weight brings the object to the ground level. It's not, doesn't concern us to move it to the left or move it to the right. Our concern about the weight, the weight ends up move an object from the top position to the lower position. That's our concern. So the direction of motion will be from up to down. So change in y will be in this direction. These two are facing the same direction. They are parallel, in other words. So the angle between them is 0. They are parallel and facing the same direction. So the angle between them is 0. This equals to 1 over 2. The mass of an object is 1.8. The final velocity is the velocity at its final position, and that is 4 squared. Don't forget to write the square. Oftentimes you find students forgetting to write the square when they substitute. Minus 1 over 2, 1.8, and the initial velocity is the velocity at point A, and that is 0.95 all squared. You work out the maths, do everything on the right at once, and then you take this one to the other side. So you'll get the work done by friction to be equals to, let's do it together. So it will be 1 over 2 multiplied by 1.8 times 4. Okay, made a mistake there. Multiply by 1.8 times 4 squared. And this minus 1 over 2 multiplied by, multiplied by 1.8 multiplied by 0.95. 0.95 squared. This will give you 13.58. 13.58, subtracting everything on the other side. So you minus everything on the other side. I'll open brackets so that I don't make mistake. 1.8 times 9.8 times 1.5 times cosine of 0. This will give you a value that is negative 12.87. We round off to 2 or 3 or more. Don't make mistakes. If you feel like our whole ground right, just write more than 2 numbers after comma, and then you'll be safe. So negative 12.87225, but I'll just write negative 12.87. It's work. So what are they used for work? It's joule. Now our answer is negative. Do we need to rewrite it as positive or not? We have to think now. Work and energy are scalar quantities. So the negative doesn't denote direction in this case. It means this is a wasteful force. This is energy lost. Work done by friction will always be negative, because remember, friction is a wasteful force. It takes away energy from an object. So this is negative. We leave it as it is. And let's see how many marks we get. You get a mark for writing this formula. It's there in the formula sheet. You choose it, and then you substitute. If you write this and that, you have not substituted. So any of this can be given a mark. Substitution is at this point. So the left hand side substitution is 1 mark. The right hand side, all of it, substitution is 1 mark. And the answer with the unit, even negative, answer positive, must be negative. Negative 12.87. If you calculate and you find it in negative, it's fine. Keep it like that. It's energy. It's work done by friction. It must be negative. And then we have done with this question. 4 marks. See how we easily got 12 marks. These 2 questions were easy. These were just theory questions. Must remember them. Oh, the first 5 marks were theory questions. Then calculations, 7 marks. You cannot get 0. You are going to write the right formula and substitute correctly. Please get marks for formulas and the substitution. If maths fails you, it's another story. But for calculations substitution should be done correctly. And then that's how we easily get these marks. Now let's see 5.6. Before we go to 5.6, there is a statement above 5.6, so we cannot ignore it. We read everything in the paper. We have time. Surface BC in the diagram above is frictionless. Ooh, frictionless. So it means from here, there is no friction. The object experiences no friction, 0 friction. What does that mean? It means the speed of the ball, of the object, at point B, will be maintained throughout, even at point C. So work done by whatever force, there will be no force in this case. Weight, remember, weight in this part will be doing 0 work, because it will be perpendicular to the direction of motion. Weight does work here, but la next is perpendicular to the direction of motion. The object is going to the left, the weight is downwards, and the angle between the two is 90. So there's no force acting. Energy is not lost between B and C, and energy is not gained. If energy was lost up until this point, that is all energy that could be lost in an object. Between B and C, no energy will be lost and no energy will be gained, because there's no friction and no force acting on an object that does work. All the forces that act on an object do 0 work. It will be normal force and weight only. So what is the value of the net work done on an object as it slides from point B to point C? The net work done, I think if we write it like this, net equals to F net. Sometimes we can it's okay to write it like this, multiplied by the displacement, because it will be moving in the x direction now, and the cosine of the angle between the two. Let's use alpha now, because we've used theta for something else. The net work done equals to the net force delta x cos y. How many forces act on an object that do work on an object between point B and C? There's no force. There's 2 forces acting. There's the free body diagram between point B and C will look like this. It will be weight, Fg, and the normal at between point B and C. There is no friction, so we don't need to draw friction. There's no applied force. No. These are the only forces acting on an object. Do they do work now? Do these 2 forces do work on an object? When an object is moving, say, to the right? No, because the angle between the two, the normal force and the displacement is 90. The angle between the weight and the displacement is also 90, and the cosine of 90 is 0. So the net work done, net, is equals to 0. In this case, they did not ask you to explain, but say explain now, but explain. And the reason will be because the net force F net is equals to 0. F net equals to 0. Or there is no acceleration. Remember, there's no friction, so we said the speed will be maintained throughout. So agna acceleration, agna net force. The net work done is 0 joules. You can write just 0 joules is fine. and the reason will be because there's no net force acting on an object. So yeah, look at these solutions, look at this paper. This is easy 13 marks, folks. It's easy 13 marks. Work energy and power, you range between 13, 14, 15 marks. You cannot lose 15 marks. These are free marks. Work energy and power, it's free. So we are done with this one. Let's check out the next video for isolation and lava. I'm gonna browse through my question papers and find another paper that we can solve together. I hope this helps. This will help you to prepare. Thank you.